So this is fun. Now we're going to talk about topic 7.2, photochemical smog. Nothing beautiful here. Okay, so previously we talked about our nitrogen dioxides or our nitrogen oxides, our NOx's, when they react with our VOCs. So both those terms we've talked about before. But when they react, they form this photochemical smog. And that only happens when we have sufficient heat and enough sunlight present to catalyze that reaction and to help it move forward. Now, we've briefly talked about this before, but this NOx, these nitrogen oxides, are produced by the combustion of fossil fuels in cars. We mentioned how they come into the exhaust, and because they're a part of the air that is drawn in, they then, under high temperature conditions, react and produce NOx. This also happens in our power generation facilities because they're doing the same thing. They're bringing in the air, which has the nitrogen in it, and then they're combusting it at high temperatures. This is what we call unintended consequences because it's because of the exhaust that these are produced, unfortunately. Then they're combined with our VOCs, and our VOCs come from many different things. They come from hydrocarbons, they're solvents, even green plants produce them, cows produce them. But the most important thing with our VOCs is that most of the time we can smell them. So there's a vapor, there's a gas, and that gas normally has carbon, hydrogen, oxygen, chlorine, sulfur, and we can smell this vapor. And that vapor is evaporating and then combining with our nitrogen oxides to produce our smog. So here's a look at it here. You can see we have oxygen in the air, we have nitrogen oxides in the air, and that's all going to combine with our VOCs and most importantly, our sunlight. So that sunlight, the temperature, the chemical reaction, and that's going to produce ozone at ground level. This is bad, and let's talk about why. This is just another diagram that goes through the whole process. So if you're more curious about how all these VOCs are produced and how this reaction happens, there's a lot more information on this page. But again, the gist is that we have our nitrogen oxides being produced, we have our hydrocarbons being produced, and then that all reacts to get our ozone, aka our photochemical smog. In addition to just the ground level ozone being produced from the reaction of VOCs and nitrogen oxides, we're also going to get PANs and aldehyde compounds. If you imagine this molecule here, we're going to attach it to another carbon here, and that could attach to another carbon or so and so. So these are added onto carbons, either those PANs or these aldehydes. And these molecules also react with the mucous membranes in our eyes and our lungs, and they cause lots of damage and even damage plants as well. So we have the ozone that is damaging, and then in addition we have these PANs and we have our aldehyde compounds. Now I want to show you this because I think a lot of times we think about smog just kind of always being there, but it actually develops throughout the day. And that is because of this morning commute. So our VOCs, they're always going to be there throughout the day. However, our nitrogen oxides are produced by cars. And so as our day continues, we have our morning commute where our nitrogen oxide and then our nitrogen dioxide are increased at very high levels. Now, like I mentioned, those VOCs are always there, but when our nitrogen oxides peak, that is when our smog is going to peak, right around noon and then into the afternoon. In addition, this reaction requires sun. which is most important. So the sun is peaking right around this time of the day, which is why our smog is going to be at its largest amount in the afternoon. So you can see an example here of how in the morning there's very little smog. It's beautiful, it's clear, there's clear air, but that's because we don't have a high concentration of motor vehicles yet. They need to produce those nitrogen oxides and many of the VOCs in order for this reaction to happen. And we need to wait for the sun to come up. So by 11 a.m., we have a lot of smog already. Now, luckily, we've learned a few things, and there's been a lot of clean air acts that have been put into use to figure out how can we reduce these VOCs from getting into the air. Because that's one of the major components. If we can reduce VOCs, then we're going to have less photochemical smog. One of the largest sources of VOCs is gasoline vapors escaping when people are fueling. And for the longest time, this was because there really wasn't a barrier between the gas tank down here and this open entry point. So what they've realized is like, all right, we're going to put in these vapor barriers on the fueling nozzle. So when you fuel up, these barriers here help prevent those VOCs from leaking out. Another way they can do this, they can reduce both the VOCs and the nitrogen oxides, is by requiring that vehicles have things called catalytic converters. Without these catalytic converters, as we talked about, the nitrogen oxide and any unburned fuel, which would produce VOCs, can leak into the atmosphere. However, by putting in these catalytic converters, they turn this nitrogen oxide that's produced into N2 and into O2, which will not create smog. And it will also turn any unreacted gasoline, it will combust it into CO2 and H2O. So now the things that are coming out of the backside is nitrogen gas, water, carbon dioxide. None of these are pollutants that are going into the atmosphere. Now, carbon dioxide is contributing to climate change. However, it is not causing irritating pollutants like the ozone. And the last new revolution that has been very helpful with reducing our nitrogen oxides and our VOCs is electric cars. Electric cars do not have an exhaust. They do not combust anything. However, we do have to consider that the electricity that is needed to fuel them was produced by burning coal and natural gas. However, most of the time, these generating facilities do take measures to reduce emissions. They have things called scrubbers that will normally kind of pull those pollutants away. And in addition, our power generating facilities often are not in the middle of a city. They're much farther outside of the city. And so they have less of an impact on humans' lives. All right, so we're going to dig into this more. Have a great day.